In this video, we're going to look at applications of periodic functions. So I'm just going to remind you that whenever you're doing applications, you use radians. So we always use radian measure. So check your calculators are in radian, or if you're going to look at the period, remember 2 pi over b. All right, let's look at one example. We've got a river flows through Tony's property. Tony measures the water level by measuring the distance d above or below the waterline t. T is the number of hours since midnight. Express d as a function of t. All right, so I've labelled the axes there. Now, remember, we need to work out, is it sine or cos, first of all? So let's have a look at where our equilibrium line is along the graph, and we can see it's actually along the x-axis, which in this case is labelled t. That defines d equals 0. So let's just go through. So we've found the equilibrium line, d is 0. From there, we can then find the amplitude. Looking at the maximum from the equilibrium line, we can see that the amplitude is 2. Now we can also see, because it starts from the equilibrium line and goes up, it must be a sine graph. So I'll highlight one cycle of sine, and we can see here that the period is 8. Now, because the period is 8, we need to use the formula. So it's P equals 2 pi over b. Don't forget we're in radians. So 8 equals 2 pi over b, and we solve that to find b. So solving that gives us b equals, so the b goes up there, the 8 goes down there, so it's 2 pi divided by 8. So the value of b is pi upon 4. We have all the things we need now, so we can say that d of t, so d is a function of t, you can just write d equals if you like, equals 2 sine pi t upon 4. And that's our function. Now I want to remind you of a couple of other things that we talked about in the previous lesson. When I was talking to you about sine and cosine, I talked to you about the most maximum that function will ever throw out on the calculator is 1. The most maximum value that sine is capable of producing, or cosine, is 1. And the most minimum value that sine or cosine is capable of producing is -1. So therefore, if we're going to find the maximum value of any periodic function, we can replace that function with 1 if it's maximum and -1 if it's minimum. So let's have a look at a second example. We've got E. coli as a type of bacteria. Its concentration P parts per million at a particular beach over a 12-hour period, T hours, after 6 a.m. is described by this function here. We're going to find the maximum and the minimum levels, and then we're going to find what the level is at 3 p.m. This would be a non-calculator example. All right, so as stated a moment ago, to find the maximum point, we can substitute the sine bit, the sine function. So the bit that's attached to the sine is this. So we're going to replace all of this bit with 1 to find the maximum. So to find the maximum, I'm going to do P equals 0.05 multiplied by 1 plus 0.5. Working that out tells me that it's 0.15 parts per million, and that's our maximum. For the minimum, I'm going to replace all of this bit, the sine bit, with -1. So the minimum, P equals 0.05 multiplied by -1 plus the 0.1. That tells me that the minimum is 0.05 parts per million. Now, the second part of the example says, what's the level at 3 p.m.? Well, we've got to work out what the value of t is at 3 p.m. because t starts at 0, but 0 is 6 a.m. So 3 p.m. is when the time t is 9. So 9 hours have passed since the beginning. So for 3 p.m. we're looking at, well, what's the value of the distance when the time is 9? Okay, so at 3 p.m. t equals 9. So just subbing into the function, the value of t equals 9, I'm going to just write the function out. So it's 0.05 multiplied by sine, and it was t pi over 12. So it's 9 pi over 12 plus that 0.1. So working that one out then, I've got to have a look at this. Let's cancel down 9 pi over 12. So that's sine 3 pi upon 12. So I've actually got to work the value out of that in order for me to work this whole thing out, because I can't, oops, hang on, that's a mistake. That should be 3 pi over 4. So I can't work this out yet without working out what 3 pi over 4 is. And we see that the denominator here is 4, so therefore we're looking for pi upon 4 within our first quadrant, and 3 pi upon 4 will sit in our second quadrant over here. Okay, so pi upon 4 you need to recognize is an exact value. It's actually 45 degrees in a isosceles triangle. So I'm going to just draw up, you should always draw up your triangles and show that you understand where those numbers come from. So I'm using right angle tricks. So of course, if I was doing this in degrees, 45 degree angle there, there's one up here too, but I don't need to write that down. I'm using an isosceles triangle, so sides 1 and 1, and through Pythagoras the hypotenuse is root 2. So sine is opposite over hypotenuse, so it's 1 over root 2. So sine of pi upon 4 is 1 over root 2. Now looking back at the unit circle, we can see that sine is positive in this quadrant here, so our value of sine 3 pi upon 4 is positive 1 over root 2. Alright, now we know the answer to this here, we can now work out all of this without the calculator. So we can go, and I'll just rewrite it, so I'm looking for when t was 9, so 0.05 multiplied by sine 9 pi over 12, which we know is the same as sine 3 pi upon 4, which is 1 over root 2, plus 0.1. Now if I work that out, I'm going to get I'm going to need a calculator, so that's the last bit. But effectively, in a natural exam, you shouldn't need to use a calculator. You'll have nice fractions here rather than decimal numbers to do, so you'd be able to work that out nicely. All right.